So, um, the next video contains joint probability mass of the bivariate capital X and Y. So, how you write this joint probability mass of the bivariate capital X and Y? You write it as like this. P, go to page number 130. Okay, please guys go to page number 130. Pij, that is equal to P X is equal to xi, comma, y is equal to yj, pij is equal to, this is small p, okay, this is small p, pij, small pij, that is equal to capital P, x is equal to xy and y is equal to yj. This is called as the joint probability mass of bivariate x and y. Joint probability mass of bivariate x, y. Now, for the individual variables x and y, we have this as like this. See. Now, you have to memorize these, whatever terms I am using, guys, you have to memorize this thing, okay? Obviously, for the individual variables, now we consider the variables x and y individually. We consider the variables capital X and capital Y individually. The individual variables x and y, we will have this like this. P capital X is equal to xi, that is equal to P capital Xi, that is equal to what it is? P I1 plus P I2 plus P I3 plus P IN for I is equal to 1, 2, 3 M. We will have Px equal to Xi, that is equal to Pxi, that is equal to, these are all small p's, okay? These are all small p's. So Pi1 plus Pi2 plus Pi3, this is actually adding row wise, you know, the row wise addition. Pi1, this is also called, just right now you have studied, this is also called marginal probability mass, okay? Px is equal to Xi, this is actually the marginal probability mass. This is Pi1 plus Pi2 plus Pi3 plus Pin. For all I is equal to 1, 2, 3 M. Similarly, we will have P y is equal to yj, P y is equal to small yj, that is equal to what it will be? P yj, that is equal to P1j. Now this will be constant, okay? This will be constant. So P1j, j will be constant, plus P2j plus P3j plus P mj for all j 1 to n. So P capital X equal to Xi, that is equal to Pxi, that is equal to Pi1 plus Pi2 plus Pi3 plus Pin for all I from 1 to m. Okay. Next, Py, this is the one marginal probability, and this is another marginal probability. Py is equal to Yj, that is equal to Pyj, that is equal to small p. These are all small p's, okay? 1j plus P2j plus P3j plus Pmj for all j, that is starting from 1 to n. So these are the two expressions you are getting. Next, we will write down, X will have the probability distribution. Now we will write down the probability distribution of capital X. Okay. We will write down how to write down the probability distribution of any particular random variable, already covered in the previous videos. Those who cannot understand this thing, how to write down the distribution, please follow my previous videos, okay, uploaded in this tutorial. So we will have we will write down the probability distribution of capital X, that is equal to capital X. We will have x1, x2, x3, dot dot dot, xn, okay, and pxi, that is equal to px1, px2, px3, dot dot dot, pxm, and the total is 1. This distribution is called the marginal distribution of capital X. This particular distribution is called the marginal distribution of capital X in the above joint distribution. Similarly, we will write down the marginal distribution of capital Y. So what will be the marginal distribution of capital Y? It will be capital Y. Say we will have Y1, Y2, Y3, dot dot dot, Yn, and then Pyj, that is Py1, Py2, Py3, dot dot dot, Pyn. Okay. Again total, again 1 over here. Is it clear? Is it clear up to this? Next, I move on to independent random variables. The next topic is independent random variable. So what it is written? Let capital X, Y be a pair of random variables. You already know this thing. Having joint distribution discussed above. Just like the joint distribution we discussed above. Now, if Pij is equal to Pxi dot Pyj, that is Pxi, X is equal to Xi, Py is equal to Yj, that is equal to P X is equal to Xi dot Py is equal to Yj holds for all values of I and j, then capital X and Y are called independent random variables. This is a very important topic, guys. Let's name it first. So if, let's write it from here, if Pij is equal to multiplication of P, means the multiplication of marginal probabilities, okay. Remember this, Pxi dot Pyj, these are the marginal probabilities. Just now we have I've shown you what are the marginal probabilities and also their distributions, okay. Pxi dot Pyj, which means, okay, P capital X is equal to Xi, comma, capital Y is equal to Yj, is equal to P capital X is equal to Xi dot P capital Y is equal to Yj. Please note this term. If Pij is equal, Pij means what? Joint distribution I and j together. That is P in one single bracket X equal to probability of X being Xi and Y being Yj together. Probability of X is equal to Xi and Y is equal to Yj being together. If this is equal to probability of X only becoming equal to Xi multiplied by product, means multiplied or product of Py is equal to Yj. If this be true, means joint probability of X being Xi and Y being Yj is equal to individual product of, means the marginal probabilities, okay. That is X is equal to only Xi and Y is equal to Yj. If this be true, then we can say X and Y are independent random variables. Is it clear? For all I and j, i's value is from C 1 to M and j's value is from 1 to N, okay, including M and N. So we will look this for an example. We will study this. So please go to page number 131. Please go to page number 131. We have an example there. This example I will be simply reading out and making you understand. I will not be writing it in this board. Just see. Let capital XY be a bivariate. Okay, yes, you know what is the meaning of bivariate, having the following joint distribution. So, let's look at the table. So, X I am plotting it in the means rows. In the values of X I am plotting it in the rows, and values of Y I am plotting it in the columns. Okay, like we used to do before. So, what are the values? Sample points. So, for X we have two values, 9 and 0.2, and for Y we have three values, -3, 5 and 7. Okay. Now let's see what are the PIJs. PIJs means these values. PIJ means the entries. What are the probabilities? Okay. Joint probabilities. So this is actually say 0.9, 0.9. Okay. First entry is 0.9. So what it means? P over of capital X is equal to X1, comma capital Y is equal to Y1. Okay. So that means, which means P capital X is equal to X1's value over here is 9. Okay. And Y1's value over here is -3. That is equal to, what is the value over here? 0.9. That is equal to 0.9. Similarly, you can plot the other ones. See, for capital X is equal to again 9 and Y is equal to 5. We have 0.15. Capital X is equal to 0.9 and Y is equal to 7. We have 0.6 and so on. Okay. Now let us look at the marginal probabilities. What is Pxi over here? Yes. What is Px1? We have Px1 and Px2 because we have two rows. So Px1, x is equal to x1. We have, yes, x is equal to Px is equal to x1. We have Px is equal to x1. We have this thing as 0.3. Okay. And for Px is equal to x2, we have 0.7. So I write it down like this. Yes. So we have P capital X1, that is equal to what we have? 0.3. And P capital X2, we have 0.7. Okay, 3 or whatever is given in the book, it is written like this. 0 carries no significance. Similarly, we will now write down the Y's. Okay, so for P Y1, that is equal to, we have 0.3 again, 0.3. P Y2, we have Py2, we have the value as 0.5, and Py3, we have the value as 0.2. Okay. Okay. So now just let us look. So we see that here that every data in the main body of the table is equal to the product of the corresponding data in the last column and last row. Example, say, just look at this value. Say P x is equal to 2, this value. Let us look at this value. So this is already data which is given in the table itself. So it's no necessary of writing it again. This data is already given in the table itself. So let's just rewrite it like this. Say P x is equal to capital X is equal to 0.2, comma Y is equal to 0.5. Okay, sorry, Y is equal to only 5. So which column I am going to look? See the last row, okay, where X's value is 0.2, and the third column where Y's value is 5. So what is the entry over there? 0.35. It is actually 0.35. Okay. Now let us look at the marginal values. Okay. Now let us look at what is Px is equal to minus 2. Only Px is equal to 0.2. What is this value? That is equal to 0.7. See, very clearly given in the table. And what is P5? That is Py is equal to, that is 5. That is equal to 0.5. Just see. So Px is equal to 0.2. That is the joint distribution of x and y. Okay. So the joint values Px is equal to 0.2 and y is equal to 5. That is equal to 0.35. That is the entry in the table. Okay. And if we look at the marginal values, see Px is equal to 0.2. That value is 0.7 and Py is equal to 5. That is 0.5. So we are getting like this. If you multiply this, you're getting 0.35. So from this we conclude that Px is equal to 0.2 comma y is equal to 5. That is equal to Px is equal to 0.2 and Py is equal to 5. See this thing. Px is equal to 0.2 comma Py is equal to 5. That is equal to Px is equal to 0.2 multiplied y is equal to 5. Now you are going to get this same thing applicable for all the values in this table, for all the probabilities in this table. This is the joint probability and these are the individual marginal probabilities. So whenever you find out any joint probability, whether it be you take another entry and you will see the same thing is happening over here. That is the product of the individual marginal probabilities, and for this reason we can conclude that x and y are independent random variables over here. So this is the conclusion. Next video we will be studying a theorem. Okay, no proofs are required. So let's stop this video here.